It seems like every day there's some new breakthrough in AI, and
Yeah,
everyone's talking about AI agents, these systems that can do these incredibly complicated things like scientific research all on their own. It's a little mind-blowing when you stop and think about it.
it is. It really is. It feels like we're right on the edge of some really huge discoveries, with AI being able to go beyond just processing information to actively participating in the process of discovery.
That's a great way to put it. And that's exactly what we're going to deep dive into today, something called PaperBench. Now, if you really want to understand what's important in AI right now, this is it. PaperBench is basically a new way to see how well AI agents can do something really difficult. Can they reproduce, like completely replicate those really advanced scientific research papers, especially in machine learning? We've been digging into the early discussions, and there's a real buzz about this, lots of aha moments.
Yep. Definitely. A lot of excitement around PaperBench. At its heart, it's an evaluation framework, like a really advanced measuring tool. But instead of measuring an object, it's measuring the intellectual capabilities of an AI agent.
Okay.
The big question it asks is, can we give an AI agent a complex research paper and have it figure out how to reproduce the results all by itself?
That's a fascinating question, but to really get this reproducing research, that's going to be way more than just reading and summarizing, right?
Oh, absolutely.
So what does it actually involve for these AI agents? What are they really doing?
It's multi-layered, to say the least.
Yeah.
To really reproduce research, the AI has to not only understand these really complex scientific ideas, which are often written in incredibly technical language, but it also has to put that understanding into action.
Right.
And that usually means writing code, and a
Yeah.
lot of times writing it from scratch. It's not just copying and pasting. It needs to be able to implement sophisticated algorithms, set up the experiments exactly as described in the paper, adjust those parameters, and then, of course, run the whole experiment.
Yeah. So it's not just theory, it's hands-on practical work, like a researcher in a lab.
Exactly. And even beyond that, there's an element of, well, call it scientific intuition, that Mac researchers develop over years of experience.
Yeah, for sure.
Well, what's so remarkable about PaperBench is that these AI agents are trying to do all of that. The comprehension, the coding, the experimenting, even filling in those missing steps that aren't explicitly stated, and they're doing it on a timescale that blows human efforts out of the water. We're talking hours, not the days or weeks it would take a human expert.
That's mind-blowing. I mean, the difference in time alone is incredible. So why is this ability to do autonomous research replication such a big deal? What does it mean for AI and beyond?
If you think about the bigger picture, if AI agents can independently validate and build on existing research at this pace, it could mean an exponential acceleration of progress in AI itself.
Wow.
Imagine AI not just learning, but actually pushing its own progress forward. That's what's so exciting.
It's like that intelligence explosion idea, right? Leopold Henbrenner's concept that self-improving AI could just take off with its own intelligence growth. Is this a sign we're heading in that direction?
What's really interesting is that a lot of people in the AI community see PaperBench as a real concrete sign that this kind of self-driven AI advancement is moving from theory into reality. We used to think of AI progress as this linear, step-by-step process, but now, with the possibility of AI doing its own research, we could be looking at a much faster, self-sustaining kind of innovation.
That's a huge shift in how we think about it. It's almost like AI going from a student to a scientist itself. And I remember seeing that OpenAI, who were involved in developing this, even talked about the importance of being really careful about the safety of this kind of powerful AI.
Oh, absolutely. That's a critical point. The very things that make autonomous research so promising also raise some really big questions about how to make sure these AI systems stay aligned with human goals as they get more independent and powerful. It's something we have to think about very carefully.
So let's break down how PaperBench actually works. We know we give the AI agent a research paper, but what happens next? What's their digital environment like? What tools do they have?
Okay, so the main goal, as we've been talking about, is for the AI to reproduce the results from the research paper. To do this, they're given access to a bunch of tools, just like a human researcher would use. They can get on the internet to search for info, read documentation, even access relevant data sets. Although there are some restrictions there, which we'll get to later. They also have access to a terminal with Python and all the programming tools so they can write and run code.
So it's like giving them a complete virtual lab, all the intellectual and practical tools they need.
Exactly. Imagine a human researcher reading a paper, then going to their computer to code, run simulations, and analyze data. The AI agent does basically the same thing, using its ability to process information and use these digital tools. Now, the benchmark they use for evaluation is made up of 20 recent, very influential machine learning papers from ICML, that's like the top international conference for machine learning breakthroughs.
Oh, wow.
These papers cover a wide range of topics, 12 in total. Things like deep reinforcement learning, how robust AI systems are, and probabilistic methods.
That's a seriously tough and comprehensive test. You mentioned a kitchen analogy earlier. Could you explain that a bit more? I think it would really help people grasp how hard this is for the AI
Like,
agents.
sure. Imagine you walk into a completely unfamiliar kitchen. You have a recipe, but it's a bit vague and missing some key ingredients. Your job is to make the exact dish, even though you've never even tasted it before.
Oh, wow. That's a good one.
That's pretty much the challenge for these AI agents. They're given a written description of a complex experiment, and they have to reproduce the results, often needing to fill in missing details and deal with all the complexities of cutting-edge research.
I love that analogy. It really highlights that just summarizing the paper isn't even close to enough. It's about putting the actual scientific method into action. And what really impressed me is that this whole evaluation wasn't just some theoretical exercise. It
Yeah.
involved the original researchers, right?
Yes, and that's one of the most important things about PaperBench. Every evaluation was developed with at least one of the original authors of the paper.
That's so important.
This collaboration is key to making sure the evaluation is accurate and relevant, because the original authors really understand their work, right?
Yeah,
They're the ones who define what a successful reproduction actually looks like.
it makes total sense. Evaluating something as complex as scientific replication can't just be checking boxes on a list. You need real expert judgment.
Right. And even for a human expert, just assessing one attempt at scientific reproduction can take ages and requires deep technical knowledge. So to make the process scalable, the creators of PaperBench actually made an automated judging system.
Wow.
They trained an AI, a large language model, to be the main evaluator.
So it's AI judging AI.
Yeah, exactly. It's kind of mind-blowing when you think about it.
That is so meta. But how can they be sure this automated judge is reliable and giving accurate scores?
That's where the evil judge comes in. It's like a second AI model that compares the scores from the automated judge to a set of evaluations done by human experts. Basically, they're checking how well the automated judge is doing.
Oh, okay. So they're benchmarking the benchmark. I like it.
Yeah. And one more important point, PaperBench is model agnostic, which means you can test all kinds of AI models, no matter who built them or how they work, all in the same standardized framework.
That's great for comparing them fairly.
Exactly.
So what were some of the big findings from the first round of testing using PaperBench, and what did they tell us about the bigger picture?
In the initial tests, the model that performed the best overall was Anthropic's Claude 3.5 Sonnet. The typical process in PaperBench is that you give the AI the research article and then watch how it thinks and uses its tools, reading the paper, writing the code, running the experiments. It's similar to what we're starting to see in those advanced AI tools for researchers.
Uh-huh.
One thing that's really interesting about code reproduction is that it's inherently verifiable. The reward for the AI is clear. The code either works and gives the expected result, or it doesn't. That gives immediate objective feedback, which can help these models improve much faster.
Like a built-in quality control system.
Exactly. The AI gets instant feedback on whether it's on the right track.
Could you walk us through the steps an AI agent takes when it's trying to reproduce a paper using PaperBench? What does that process look like?
Sure, no problem. The agent starts by really digesting the paper. Then it creates the files and scripts it needs. For example, it might create a reproduce.esh script, which is a common way to automate commands in Linux. Basically, it sets up its whole work environment before even attempting the reproduction.
Oh, okay.
Then, once everything's ready, it starts the reproduction process. The results and code are then submitted to the automated judge. Now, it's important to understand that the evaluation isn't just a pass or fail. It's a much more detailed assessment based on the specific criteria in the evaluation rubric.
Right.
And remember, that rubric was developed with the paper's original authors.
So it's not just did it work, but more like how well did it work and where did it succeed or fall short compared to the original research.
Exactly. It gives you a much more nuanced understanding of the AI's performance. The evaluation framework gives a numerical score based on how much of the research was successfully reproduced. For example, an attempt might get a score of, say, 34.7% on one paper. Across the whole PaperBench evaluation, Anthropic's Claude 3.5 Sonnet got an average score of 21%. Now, that might not sound like a lot at first, But you have to consider how insanely complex this task is.
Yeah.
We're talking about AI doing cutting-edge science on its own. It's huge.
And let's be honest, human researchers aren't perfect at reproducing findings either, are they? I've even read about cases where scientists struggled to reproduce their own work from a while back.
That's a really good point. There's one example where human researchers spent over 60 hours trying to reproduce their own published research. Even in their best attempt, they only got a score of 41.4%. But an AI using PaperBench got a score of 26.6% on the same papers in much less time. So, it shows how hard research reproduction really is. And it also highlights that even this initial AI performance is really significant. And given how fast these models are improving, this is likely just the beginning.
That puts the 21% score in a whole new light. It's not about perfection right now. It's about demonstrating this incredible capability that's rapidly evolving. Now, to keep things fair, I'm guessing there are safeguards to stop the AI from just finding and using the original author's code or data.
Oh, absolutely. There are several key things they do to prevent what you might call cheating.
Right.
One big one is that the AIs aren't allowed to directly download the original author's code. They use a blacklist of websites and repositories to enforce this. This forces the AI to actually understand the paper's methods and write the code from scratch based on that understanding.
That's so important to make sure they're actually learning, not just taking the easy way out.
Right.
What other mechanisms are there to ensure fairness and keep the evaluation reliable?
Another crucial thing is that the AI's code is run in a completely fresh, isolated environment. No history, no cached data. That way, the AI can't use any pre-existing conditions or past interactions to get the result. It has to start from scratch every time.
That's like a totally sterile lab environment.
Yeah.
So any success is truly because of the AI's ability to understand and implement the research itself.
Exactly. And let's not forget that granular evaluation system. It's not just a yes or no about whether the reproduction worked.
Right. You mentioned it earlier, and it seems incredibly important.
It is. Every paper in PaperBench has a very detailed evaluation rubric that spells out exactly what a complete reproduction would look like.
Okay.
What's really interesting is that the rubric has a hierarchical structure. At the top level, it's just successful or failed. But as you go deeper, it breaks down the paper into smaller and smaller parts and assesses whether the AI reproduced each of those elements.
So you get a much more detailed picture of where the AI did well and where it struggled. It's like a performance report for each attempt.
Exactly. And that aligns with the idea of process-based rewards, as opposed to just rewarding the final result. A purely result-based system would only care about whether the final experiment worked perfectly. But PaperBench's granular evaluation looks at the successful reproduction of individual parts and steps, giving credit for each correct part of the process, even if the final reproduction isn't flawless, like a good teacher grading a student's work.
That's a great analogy. You get so much more information that can then be used to train and improve these AIs. Now, running these complex experiments can't be cheap. What's the cost of using these AI agents in PaperBench?
It can be pretty expensive, yeah. These AI agents can run for a long time, sometimes up to 12 hours straight, processing tons of data and doing all those calculations.
Right.
And that uses a lot of computing power and infrastructure. Current estimates say a single full evaluation can cost hundreds, maybe even thousands of dollars in some cases.
Wow, that's a big investment. Who's willing to pay for this kind of research?
Well, it's a lot of money up front. But think about the potential payoff. For big tech companies and research institutions that are really focused on developing truly autonomous, self-improving AI, these costs are probably seen as a small price to pay if it leads to major breakthroughs.
Yeah, I can see that.
The possibility of AI accelerating its own development through doing its own research, that's potentially transformative. And we're seeing really fast progress in the core abilities of these models. How they use tools, how they reason through complex problems, how they interact with intricate environments. It's all improving at an incredible speed.
It feels like we're on the cusp of something truly revolutionary. So as we wrap up this deep dive, what's the big takeaway? What does it mean that AI can now reproduce scientific research, even if it's not everything yet?
Well, it's important to remember that AI isn't quite able to replicate the full scope of what human scientists do just yet. There are still limitations. But the progress in this area is undeniable. We're seeing these incredibly advanced agentic frameworks being developed that give AI more initiative and let them tackle more complex intellectual tasks. And if we go back to that intelligence explosion idea, if AI reaches the point where it can not only fully reproduce research, but also come up with its own new ideas and improve itself. That could be a total game changer for humanity.
That's a pretty big thought. AI becoming a true scientist, coming up with his own discoveries, that raises so many questions about the nature of science and the future role of human scientists.
It really does. I think the main thing to take away from PaperBench is that it's not just another benchmark. It's a glimpse into a future where AI might have a much more active and independent role in scientific discovery.
Absolutely. So to all our listeners out there, here's something to really think about. If AI is increasingly taking on the work of reproducing and maybe even creating scientific knowledge, what does that mean for the way we do science? What new roles and possibilities does it open up for you? It's a question that deserves a lot more thought and discussion.
I couldn't agree more. It's a really exciting and crucial area to watch.
Well, on that note, thank you so much for joining us for this fascinating deep dive into PaperBench.
It was my pleasure. Thanks for having me.